chapter 10A. I know we're skipping stuff, but just go with me. We'll go in the order that is best, or what I think is best. And in WebAssign, you guys should have had, if you want to double check me if you're bored, but otherwise probably shouldn't be on computers unless you're just looking at the Jamboard. I believe 10.1 showed up in your WebAssign, and it's also shown up in Google Classroom as of just a couple moments ago. Here we go. You guys already wrote that down, but before we do that, woohoo, what's this page for?
Unit circle.
Unit circle. I want you guys to tell me, oh, that's going to be rough. Tell me go when it hits the 6. Tell me go when the second hand hits the 6. Yeah, the second hand's a little red one. The little red one that goes around the circle.
I do that.
Yeah, I know. Those of you guys with iPhones and smartwatches, you don't know how to tell time anymore. When it hits the 6. Give me a wind up.
3, 2, 1, go. Whoa.
I already have it down though.
Square root of 3, over 3, 1 square root of 3. Count up. Count down. Divide. How many seconds?
16.
I have the entire first quadrant of the unit circle, and I could write it on any quiz, on any test, on any math placement, on any SAT, right?
Yes.
Okay, now, why am I writing this? Because in this chapter, I should say, in this section, trigonometry isn't something that's huge in the entire section. It would be if we went to chapter 10b. There's a whole other way of looking at functions called polar. Polar having to do with kind of like the world, latitudes, longitudes, something that we can call kind of like spherical geometry. Spherical geometry looks at things as being placements on a sphere, right? I know, my perspective is a little bit off. It's been a rough day. We have our spherical geometry versus good old-fashioned just coordinate geometry. Coordinate geometry says, hey, guess what? We're on a nice flat XY. Spherical geometry says, no, we're not. This one, we would use some sort of measuring, like r equals f of theta. And to use thetas, to use angles, trigonometry comes into play. So this would be a lot more active in the sections towards the end of chapter 10, like chapter 10.6, 10.7. We're going to kind of stay for this year in what we're used to. Does that make sense? So most of this chapter will be good old-fashioned this, but in this very, very, very first section, lines. You're like, what else do we really have to learn about lines, right? In Algebra 1, we learned the most basic way of writing a line is what? Y equals mx plus b. Technically before that was ax plus by equals c, but that one's lame because it doesn't have an m in it, and m stands for what again?
Slope.
That's pretty important for a line because a line is defined as a geometric figure that has a constant slope. What else has a constant slope? Well, you might ask me what else has a slope, but unless you want me to talk all about calculus for the rest of class, maybe don't ask that question. Instead, just go back to a line has a constant slope, a constant rise over run, and then the b is the y-intercept. But there's another way of writing a line, isn't there? Y minus. Y minus.
Y minus y1.
Y1 equals. Close. What do you need first before the x minus x1? M. So y minus y1 equals m times x minus x1. It's a rearrangement of m equals y2 minus y1 all over x2 minus x1. And it's known as what kind of form? Point slope form. You're like, we know slope-intercept. We know point slope. We know there's another nasty version where we can get y by itself to see the m. What else is there to learn about a line? Well, it's more of using a line to introduce a deeper idea. And to do that, I need you guys to remember tangent. Maybe tangents of weird angles, maybe tangents of normal angles. But I need you to remember tangents. Yeah.
What is it in the bottom right one?
Undefined because 0 divided by 1 is 0. 1 divided by 0 is undefined. It's an infinite slope, like a vertical line. So vertical slope is infinite or undefined. Sorry, UND for undefined. Or I could just do an infinity. That would work too. The problem is it could be positive infinity or negative infinity, so it's a little dicey. So check it. What things as I try to help you. M is equal to, what did we already say today? Sorry, what did I say? Did you hear it? M is equal to what?
Y2 minus Y1.
We could actually plug in stuff and talk about it that way. But if we were to think about the concept or the idea, what are we finding when we find a change in y's? How much something has what? Risen or changed vertically. But can we use rise for change vertically? Is that okay?
Yeah. Yes.
And if we were talking about x2 minus x1, we're figuring out a change in x, otherwise known as commonly run. So normally we think of m as rise over run. Now it's a little ironic, because rise, whenever you see that word, you assume it's going what? But is it possible for a line to go? Yes, of course. So it's a positive rise or a negative rise, and all of a sudden we're like, oh, that's right. In math, we can do a positive or a negative to change up the direction of things, right? But coming back, slope, something standard, something boring, something maybe not too exciting to you yet, and yet something very fundamental to a connection that we're about to talk about. New vocab maybe for some of you guys, but maybe not that new after all. Would it make sense that inclination, ooh, what word is in inclination? Which has an English meaning. Are you so inclined? I am so inclined. I'm inclined to think, right? Like we could put an English meaning on it, but mathematically, if you hear about it inclined, what do you think? You're driving a Bakersfield and there's some sort of percentage grade. You gotta turn off your air conditioner, make sure you don't overheat. Maybe that's only for semi-truck drivers. But anyway, an incline, a grade, a slope, a steepness. Does that make sense?
Yeah.
Okay. If you're going down an incline, what do you gotta watch out for? Maybe your knees if you're hiking, maybe your speed if you're driving, right?
Yep.
Maybe your brakes if you're a big old truck, and that's why they have those big old gravel off-ramps, because if their brakes overheat, what happens? What's the disaster that could occur if brakes overheat too much on like a semi? The brakes break. Yeah, they stop being able to stop, basically. So a runaway ramp is literally for, like, if a truck's brakes are overheating, then they can go ahead and hopefully be stopped by the gravel and not crash into people. But coming back. Incline, steepness, slope. What's the mathematical definition? What do you guys see? Inclination is actually not a percentage grade, but instead it's a
Angle.
Have you made a note of the word positive?
Yes.
Because haven't we before in math talked about negative angles? Are we going to want to talk about a negative angle?
No.
Not by mathematical definition. Okay, positive angle. Measured in what kind of position? So from the normal x-axis, or due east if we're talking about it that way. The standard position from the horizontal to the line. Angle must be in the intervals. Could be 0. If it's an angle of 0, what's true? If my incline is 0 degrees or 0 radians, what's true? Straight as in, technically all lines are straight. But I know what you're saying. It could also be known as 180, but there's a better way of thinking about it. If it was 0, it wouldn't be vertical. That'd be 90. Horizontal. If your incline is 0, what are you talking about?
It's just
Right? Right? Wait, that straight line can be somewhere else besides the x-axis?
yes.
Yeah, I'm just talking about how sloped it is, right? What's my inclination? It could be 0 wherever that straight, flat line, maybe better than straight line, occurs. But the angle must be in the interval 0 to question. What other angles would I need to be able to get all lines? Could I go 0 to 90? Would that get them all?
Or 0 to 190.
0 to 90 would get all what kinds of lines? From flat to straight up and down of what slopes?
Positive.
Positive slopes. You see it? 0 to 90 would give me all the positively sloped lines. But I also need negatively sloped lines, right? So negatively sloped lines. But why would I not include 180?
So there's no slope.
It's all the way back to 0. It's back to no slope. Does that make sense? So I wouldn't say 180 when I could say 0. To get all the different possible lines that are positively sloped or that are negatively sloped, all I need is 0 to 180, not 180 because I'm right back. That's 0. Brendan.
0 is positive slope.
0 is the boundary of positive slopes. So open interval 0, open interval 90. So at 0, I would have a horizontal line, right? At 90 or pi over 2, I would have a vertical line. So then I could say that all my positively sloped. Good question, I could write that down. All my positively sloped would be in between 0 and 90. Good clarification, right? So not at 0, not at 90, that's flat, that's vertical. And then all my negatively sloped would then be where? 90 to 0, but we'll use 180. We're just going to put parentheses, because what did parentheses denote again, guys? It's bounded by, it's limited by, but it's not touching, including, it's like a less than, greater than, without the or equal to. Does that make sense? So at the 0, I have horizontal. At the 90, I have vertical. Anywhere between 0 and 90, the positive angle that gets there would be showing positive slope. And then 90 to 180, in between, but not including, negatively sloped. So Brendan, I would call 0 and 90, I don't need the adverb, sorry. I would call them separators, but neither positive nor negative. Although, if you think about 90 or a vertical line as being infinite, depending on what's happening before or after I get there, I could talk about that as being a positive infinity or a negative infinity, but that's maybe a topic for another time. Because it needs a bit more going on for me to make that deduction. So for right now, we'll just say infinite or undefined. There was a question, and I missed it.
Yeah, it got answered.
What were you thinking, Ryan?
I was just gonna ask if 90 degrees would be considered a positive incline, but it's its own thing. It's vertical.
Yeah. And you have to think about it like 10.1 is kind of cool because it sort of introduces a little bit of like some calculus ideas as well. And I don't mean like calculus in the idea of like we're going to be doing some solving in calculus. We're going to be doing some plugging in. We're going to be doing some algebra, a little bit of trig. But we're doing it in context of this much different topic that we haven't really broached a lot on. But I can introduce a couple things here in 10.1. I can introduce a couple things through chapter 9, section like 3 and 4. I can introduce a couple things here and there. But this idea of whether 90 is positive or negative, you've learned undefined slope probably since you were like in pre-algebra or algebra 1. They just called it undefined. Maybe a cool teacher was like, ooh, it's actually infinite. The problem is, unless you have some sort of idea of how you're getting to that vertical line, having a vertical line in math, just having like a plain old vertical line is pretty rare. It's more of usually we're approaching a vertical line, getting closer and closer and closer. Infinity is not like a, I'm there. Infinity is like a, I'm headed forever. Does that kind of make sense? Like 10, I can get to a 10 in some sort of like $10 or 10 years or 10, I mean, put a label on it and we can get to that 10 usually, right? I won't ever get to 10 feet tall, but you know what I mean? Like 10 is an increment that we can talk about solidly. Infinity is more of an idea. It's not a number because it's more of a, it'll always be growing. But the problem is, without seeing some sort of context of what comes before and what goes after, you don't know necessarily if this is what's happening as I'm growing positively forever, or if it's something I'm growing negatively forever. What do I mean? If I was coming from making something steeper and steeper and steeper and steeper positively, then this vertical line could be a positive infinity. Because the idea is as I get steeper and steeper and steeper and steeper, what's the slope of 1? Well, up 1 over 1. What's the slope of 5? Up 5 over 1. What's the slope of 10? Up 10 over 1. What's the slope of 100 and 1,000 and 10,000 and 1,000,000? You're getting closer and closer and closer. This could be a positive infinity. But if I'm going there a different direction or a different way, You guys see how possibly I could be coming from negatively sloped? Down one, back one. Wait, down one. Down one, forward one. There we go. Down 5, forward one. Down 10, forward one. Down 100, forward one. Down 1,000, forward one. Down 10,000. This vertical line could be arrived at two different ways. It could either be denoting a positive infinity or a negative infinity, and thus we call it undefined, just to be easy. Anyway, that's maybe a topic for another day. The key word is limit. Anyway, coming back, slope, an alternate formula. Wait. How did a tangent get in here? I already ruined it a little bit. I showed you the cheater chart and I highlighted the tangent column, but the question is, why is he here? So let's review what we know about it. What do we know about tangent, besides the fact he's a line in the cheater chart? Go back to trigonometry. Who is tangent? Tangent is sine over cosine, but more specifically, go back to the beginning. And Sasha, you just said tangent's what? Y over x, otherwise known as? What? If I just add a little over a all of a sudden I'm like, oh, no way. Because it's an opposite over an adjacent of what geometric figure? And a triangle, couldn't I talk about his hypotenuse as being a line?
Yes.
And couldn't I talk about this as being the run? And this as being the rise? And so when I say a y, I'm not talking about one little lonely y value. When I talk about y over x, I'm talking about a change in y's. You guys remember that? And when I'm talking about x's, I'm talking about a change in x. When I'm talking about sides of triangles, I'm talking about distance change. So this rise would be my y2 minus y1, otherwise known as the opposite side. And this run would be the x2 minus x1, otherwise known as the adjacent side. So all of a sudden we have this correlation between a tangent and a slope. And maybe this starts to give us a way to find slopes of things other than lines, but only if you know a little bit of calculus first. All right, so first of all, theta, we just named him. Who is theta? He is known as our, starts with an I and ends with a Asian. I didn't give you all the words this time, or all the letters. Inclination, we just talked about him. That's funny. I know, so usually I give you all the words, right? Or all the letters. Inclination. How inclined the line is. A line meaning the hypotenuse. So we can think about our line as being the hypotenuse. We can think about the incline as being the theta. M, we already know, that's easy, that's basic, but I'm making them a bit more interesting now. Slope. So if I want to find the inclination, we get to go back to Algebra 1, everybody. It's saying find the inclination, but to find the inclination, ew, that's ax plus by is c. We don't like that form. What form do we like? Please allow me to enjoy this class. Algebra 1 is like, okay, let me teach you how to get y by itself again. For you guys, can you just get y by itself? What do we have? For letter A, what's my y by itself?
Y equals
negative 2.
No.
Negative
No,
2
not
plus
negative.
minus
Minus
negative 2.
X
X minus 2.
X minus 2. X minus 2.
Someone walk me through why it was tricky. It was. I know. It wasn't quite fair for me to do that. Walk me through your steps. Walk me through your steps to get to what you are pretty confident is the right answer. Jackson, go ahead.
Just subtract the x,
Yeah.
and then you get negative y equals negative x plus 2, and then just divide it by negative 1 both times. And then you get subtract it.
Does anybody have possibly, even though that is the way your Algebra 1 teacher would have definitely taught you to do that, has anybody come up with possibly a simpler way of doing this Without needing to divide by a negative at the end. Ryan, you can go.
You add the y and then subtract the 2.
Yeah.
I would agree that's the easiest way. Some of you, though, are very good little robotic, this is the way my teacher taught me, and that's okay as long as you go carefully. But mental mathers, you usually take shortcuts. If you take shortcuts to a process that's harder to begin with, the odds of you making a mistake are higher. Does that make sense? So maybe go with the creative route and be like, if I add, things are safer. Yeah, you're right. Things are safer. Add the y, subtract the 2, and be like, woohoo! All right, better be. What do we got?
Subtract 2x each side and divide by 3.
Y equals negative 2 over 3x plus 2.
Cool. Using the steps that Ryan Krikorian said, subtract the 2x and then divide everything by 3. Everything by 3. Do what you need to do to get that answer. Can you get it? Double check that I'm right. I don't need that there. Those aren't constants. I'm just denoting m for the a and m for the b just so that we can look at it. Kiddos, why am I getting m again? What was the objective of this entire problem?
Find the inclination.
It's a question. Why am I able to go ahead and say my inclination on this one is pi over 4, otherwise known as 45 degrees?
I don't know. 1 because of
Tan
theta
of theta needs to equal.
equals 1.
Oh, and our slope is just tan theta.
And what did I draw at the beginning of class? Square root of 3 over 3, 1 square root of 3. Anytime you have a slope of 1, you're always talking about a 45-degree inclination, aka a 45, 45, 90 triangle.
Oh, that makes sense.
Otherwise known as an isosceles triangle where the opposite and the adjacent are the same. Ryan Krikorian, go ahead.
How'd you get 1? I understand they got 45, but how'd you get 1 again?
Oh. Because we had to remember how to get the n. So what was the understood coefficient in front of my... There you go. Just remember the understood one. It's a little bit easier the next one, except this next one, am I going to be able to give you guys like a solid, definite answer?
No.
Not without a calculator. Why?
It's not in the unit.
Square root of 3 over 3, 1 square root of 3, 0 or undefined. Nope. Alright, I'd have to approximate. Now I could approximate maybe if I knew what the decimals were for square root of 3 over 3 and 1 and, well, I know what 1 is, that's 1.00, but who are these guys? If I was really cool, if I was like Mrs. Leon, oh, the day when no one remembers her, how sad will that be? Square root of 3 over 3. We love Miss K though. Square root of 3 over 3. 0.577. Ish, otherwise known as 0.56. 1, well that's easy, that's 1.00. Square root of 3. Miss Leon had all these memorized. 1.73. 2, if I want to be super specific. I forgot you guys wouldn't know what I was alluding to. Where would negative 2/3 go? What is 2/3 as a decimal? Oh, please tell me you know that one. 0.6666666666666. That would go somewhere in between here to here, and it'd probably be closer to here, right?
Yes.
If I was to eyeball it, I'd probably say like 35 degrees. But how are we going to actually figure out what it is? Yeah, exactly. Because can't I take tangent inverse of anything?
Yes.
Now careful, was this a positive 2/3 or a negative 2/3? So when I go to take tangent inverse of a negative 2 divided by 3, and if I'm thinking in terms of what my brain normally thinks in, maybe I should be looking at this in degrees just to get a better handle on it. How close were we?
I was right.
Not too shabby, except, is that my inclination? The answer is no. Weather science is going to mark it wrong, and you're going to freak out a little bit until you remember the definition of inclination that I had you circle. Paul circled it. Paul, what's inclination? What'd you circle?
Positive.
Positive angle. Oh, no! So my calculator doesn't just automatically give me inclination? No, but it gives me all I need for inclination. Why is it giving me negative 33.690? Negative 33.690 is not the inclination, but can I use it? The answer is yes. Can't I go from some arbitrary point down to and over 1, 2, 3? Can't I draw a line? And can't I think about what it's giving me when it gives me negative 33?
180 minus 33.69.
It's giving me one way of getting to a line, but I want the other way of getting to the line. How is Brendan spitting out the answer he's spitting out? Go ahead, say it one more time, buddy.
180 minus 33.
Why is he doing 180 minus? What's he doing? Why is he saying 180?
Because then you can get a positive angle.
And why 180? Why not 360?
Because the parameters are 0 to 180.
And question, what are we trying to do this on again? What is this forming? What are we working with?
Inclination.
Of a
Obtuse angle.
of a
A line.
of a line. And how many degrees are in a line? So is negative 33 one way of getting to a place on the line from a horizontal? Yes, but what's the other way of getting to it? Well, think a linear pair. What's the other guy? Well, the other guy is 180. Take that away. Not take away the negative, but add. Inclination says, I look up. I'm optimistic, not pessimistic. I always look up to the line, not down. You can either add 180 to the negative number, or you can do 180, take away the positive magnitude of that number.
So it'll mark it wrong if you put the negative 32.
If you give me an inclination that is negative, you are not giving me a proper inclination.
Okay.
Does that make sense?
Uh-huh.
So it's not just saying find an angle to the line, it's saying find this vocab word that we just defined to be only the positive way of looking at it. So then we would go ahead and say plus 180. And as you guys have already found out, that is 146 point what?
3-1.
Dun, 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 dun. Think up, not down. Ooh, there's a life lesson in there somewhere. Half full? Empty? What? I don't know. Okay.
And just like on the one on the left, you found like the inclination by just taking like the inverse.
Well, I got the inclination by knowing my unit circle technically.
Oh, and then so it's just like where is tangent equal to 1? That's 3,000.
Natalie and Sasha are reflecting back over the year. All right, the rest of us, let's keep going. So, find the slope given that. How could the question change? That's something for seniors to be doing right now, not juniors and sophomores, you silly goofs. But thank you for your opinion. Always, always welcome. Find the slope. How do I find the slope if I'm given an angle? Find the slope. Take your time, take your time. Find the slope. Given the angle. Wait, no. Slope. Y2 minus Y1. Nope, scratch it. Well, scratch it unless you want to draw this guy. You can draw this guy if you want. 2/3 of a, we just had pie day. Of a pizza or of a calzone? Yep, 2/3 of a calzone will put you about there-ish, right? Is that cool? 2/3 of a calzone will put you about there-ish, right? Now, remember, inclination, that's just starting at some, like, horizontal, like a Dewey sort of thing. Or starting along the ground, and you have something coming out of the ground. But what we're finding is the inclination of what again? I just asked it recently. Brendan answered it last time. The inclination of a line. This is the main player in this section. You guys understand? The main player is the line. It's another application of what we've been doing. Here's my 2 pi over 3. Otherwise known as 120. 2/3 of pi's, or 2/3 of 180s, or 260s. So to find the slope, don't I need the rise over the run? I mean, could I think of unit circle to get that rise over run? I guess. I guess you could think of what is the sine and what is the cosine. And when you think of, because, I mean, Natalie, you said that, right? Tangent is sine over cosine. Oh, that's right. Trig relates because it's like I can draw a triangle to a line and that can get me my slope because I don't have y2s and y1s. All I have is an angle. But I do know this angle will have a sine of, anybody, square root of 3 over 2? And we'll have a cosine of, anybody, -1/2? Did you realize when we were doing trig all along, we could have also been doing slopes? Interesting. But what's another way of getting there? Yeah, isn't there a formula? The formula says m is equal to tangent of theta, and tangent of theta is not even having to draw that, not even having to think about that, but just say what is tangent of 2 pi over 3? And tangent of 2 pi over 3? Square root of 3 over 3, 1 square root of 3, square root of 3. But why am I going to put a negative on it? Look at the line! Of course it's negative! Or think about the trigonometry, second quadrant, all students. One of them is negative, so tangent is negative. Because a sine over a cosine would be a positive over a negative, which is a negative. But of course the line is negative. Look at them. Tangents are slopes. Is it sloped up or is it sloped down? Exactly. But isn't there a formula? We can just plug into the formula. I made it complicated for a second, but then I made it basic. We could plug into the formula. Or we could realize the idea. Either one has us finding the exact same thing. I'm going with the one whose hand is up first.
So 2 pi over 3, that's 120 degrees, right? So for that, wouldn't it be x is -3 over square root of 2, and then y would be 1/2?
If we were in the unit circle, yes. I don't know where you're standing on the line, so I can't necessarily say that x and y is perfectly that, but I can say the ratio of the opposite over the adjacent will be that ratio.
Because what I did is I just divided y by x, and I got a different answer.
Well, but x would have been -1/2.
I said positive 1/2.
Nope. Positive goes that way, negative goes that way. That would have been the answer. Or the reason why you were wrong. But y over x would have gotten you, should have gotten you the same thing, so you would have had negative. Sorry, positive. I'm sorry, Ryan, not the positive, because I'm going up. But the bottom part would have been a negative. And then if you want to do this like the algebraic way, you could have multiplied by the reciprocal. Or I would just reduce the halves because I have a half on top and a half on bottom. Either way, I end up with my -3. You just got to remember your quadrants. You're in the second quadrant when you go past 17. That's what you missed. Ryan, you
Sorry, how did you go from when you use the formula from tangent 2 pi over 3? Like, how did you get -3?
Oh, I knew my unit circle, kiddo. So it's a 2 pi over 3 or it's a 120, so I knew my sine, I knew my cosine. Now, as I told Ryan, I don't know exactly where I'm standing on the line, so I kind of just made it to where I'm standing one up, or, yeah, one not up, but one out, one up on the hill. But remember, with lines, we can pick any 2 points, so anywhere you picked it, it would just be some, like, multiple of that and some multiple of that that would have the same ratio, because similar triangles are proportional, so that division will always result in this.
Okay.
Does that make sense? Good question. Ryan Kokorian?
So whenever something is closer to the y-axis, x is always 1/2, like 30 degrees.
Oh, you're reviewing your triangles. Yeah, in the unit circle, do you mind if I do it first quadrant, because it's a little bit faster? Whenever I am closer, yeah, I have that 1/2. Whenever I'm in the middle, that's when I'm at my square root of 2 over 2. And whenever I'm at the farthest, just using these as an example, And so this is my farthest or my longest up. This is my middle because it's isosceles, it's 45, 45. They're the same. And then that's my shorter distance up. Those are going back to our 5 key numbers of, 1 and 0. So 0 counts up and 1 counts down. But yeah.
Yeah, I just forgot about that.
No, you're good, you're good. So ready, set? Use what you know, go. We have this formula, m equals tangent of theta. We also have this like intuitive way of visualizing, if it's helpful. But we have the formula. Ah. I hear some people in the back saying y2 minus y1 all over x2 minus x1. I do believe we have to review some algebra. So just in case you don't remember that formula or you would like a quick refresher, we don't even have the m in this one. We don't even have the inclination in this one, but we have all we need if we just review and remember. We're just making connections, guys. We're just making connections.
What's the one where it's like y minus y1?
Point slope.
Oh.
And that's the one that I believe, was it Brendan Jackson? Somebody was saying earlier. Y minus,
y1 equals
it uses the relationship of m, but it says I can use that to get an actual equation if I just make this a general and make this a general. So I can put in a point, I can put in my slope, and I can have another way of making a line that does not, which is why it's so powerful, which does not need the intercept. This one says, give me the intercept or else you gotta like play around with it. The other one says, I don't need an intercept, I just need any point. That's just a variation of that. Generalizing y2, generalizing x2. Sorry. What's going on? Oh, got it. It's my puppy's appointment tomorrow. Okay. He's not a puppy. He's a grown-up puppy. But there we go. What did you guys get? You subtracted.
Square root of 3.
Oh, you went the other way.
What about negative?
It should end in the same place though, right? Because I'm going to get a negative root 3, but I'm also going to get a negative 1, which means I'm also going to get a positive root 3. So either way, in physics we would technically say final minus initial, but I guess that would have been that guy minus that guy. So,
Is that the answer?
what is that the answer to? I said y equals. It's not a y. What variable should have been there? Is that what they're asking for?
No.
No.
You need to do inverse.
But is it necessary? And according to Ryan, you in the back, you can take tangent inverse, or according to me, you can think square root of 3 over 3, 1 square root of 3, and you can land that.
2 over 3 pi.
Oh, pi over 3.
If you want to double check, is it actually a positive inclination? 60 degrees says positive. I can do 0. Root 3, which we already said is 1.7-ish.
Oh, this makes sense.
And 1 and 2 root 3. 1.7-ish, actually 1.8-ish times 2 would be 3.6-ish. 3.6-ish would be about here. Question, is it a positively sloped line? Yes. Where's my inclination? That's interesting, but your inclination would be wherever the horizontal is from that, measuring that horizontal, that's where I would get that 60 degrees. If it's not centered at 0, 0, I'm not actually measuring from the positive x-axis. I'm measuring on the line from due east, and that is my inclination. Jackson.
How is square root of 3 minus 2? Like, what? How do you solve?
Yeah, I don't.
Oh, think like terms.
Stuck on our units.
Algebra. If you did x minus 2x, wouldn't that be negative x? Because I do 1 minus 2 and I combine like terms. I did the same thing, except my unknown was a root 3. What's 1 root 3 is take away 2 root 3's, negative 1 root 3. Negative 1 root 3 over negative 1 ends up being a positive root 3.
Oh my gosh.
Oh, you guys are cute. We'll blame COVID.
I said you took the
Yeah.
We'll blame COVID. We'll blame COVID. Baron.
Yeah, so where's the horizontal line come from?
It's just
The yellow line?
I marked a point. I marked a point on the line as though I was standing there, like I started and I finished, right? And it was just directly like due east from wherever I am.
But why is like it's not on the original point?
Well, it couldn't be down here because this is not, or I guess it could be. I'd have to go back here though. I guess it could be back here. But a lot of people get confused by that. But you're right, I could show 60 degrees right there also.
Oh.
I could show 60 degrees from any place. Does that make sense?
Yeah.
Good question. So I could be there, but I would have to go not to the origin, I have to go back to the line and then measure. Right, Corian?
So it could also be 210 because since the
Except an inclination is defined to be 0 to 180. So 210 would be redundant.
so why isn't it?
It would be redundant. So we said we just want one inclination for every line, not two inclinations. So instead of finding this and finding that and finding that, I'm just trying to find incline. How inclined is it? So I'm not going to go around finding coterminals or finding any angle bigger than 180. I just want the one. We would think I'm trying to make this invertible. I'm trying to have it pass the horizontal line test. I want it to be 1 to 1. I want there to be one answer and one answer only. So what you said was another way of measuring, but not what I would say a practical one for most applications.
So it's only in the first quadrant?
Well.
And the second quadrant?
But in the first quadrant for positive angles. In the second quadrant for negative angles. Third quadrant would repeat, fourth quadrant would repeat. Does that make sense?
Yes.
So your logic isn't wrong. 210 would return to the line, but in most practical circumstances, where like the word inclination would be, like inclination is usually like the incline of an actual ramp or of an actual hill or of an actual, like usually we're using incline for some sort of object. And for most objects, you won't be measuring greater than 180 because that would make you like go through the hill or that would make you like go underground. Does that kind of make sense?
Yeah, okay. It's just like there's a restriction where you
Right. To make it to where I only have to worry about one answer instead of multiple. Solid question though. Especially based on what we did with trig where we had lots of different answers, right? So what if I was to throw something else at you? It says something about an angle. It says something about us wanting to find an angle. I'm going to go ahead and have this be twofold. It's a great time for a break after. You gotta retrain it. Alright, cool kids, for those of you guys joining us on the video, let's check everybody's work. You were supposed to get y by itself because that's how we graph lines. We want to think about, and I heard it might be helpful for us all to review, graphing lines takes y equals, guys help, please. Graphing lines takes y equals mx plus b. Like I'm showing my algebra kids. This is our starting point. And we start by graphing 0b. And then we move.
That's good to know.
Then we move our rise over our run. Knowing that we can always make an understood one if necessary. For instance, over here, if I want to do my slope, I'm going to think 2 over 1. I can always have it over, over an understood 1. So if I go to graph, I'm going to go ahead and get my intercept at -4. I'm going to go ahead and do my rise of 2, run of 1, rise of 2, run of 1, rise of 2, run of 1 until I run out. Okay, cool. To do my other one, I'm going to start at +3. I'm going to do my rise, but it's a negative, so it's an anti-rise, otherwise known as a fall. 1, 2, 3, go over 1, 2, 3, and 4. 1, 2, 3. 1, 2, 3, and I don't know, something over here 4. Oh, wasn't too bad. Cool. Question. What was our goal? I didn't even ask you to keep going. I just said to graph the 2 lines and then take a little bit of a break. But what was our goal?
Find
Find the angle.
So what's the dilemma about the angle between?
Which
Or
is?
which one?
But you only need to find
Because
one.
from geometry, what do we know about vertical angles? This guy's going to be congruent to that guy. And this guy is going to be congruent to
This
that guy. But are they the same angle?
No.
So I have 2 different angles to think about. Now, what if I was to take like an intersection? What if I was to take like an intersection? Okay, and then what if I was to think inclination? Inclination goes how? Positively, right?
Yes.
So I could think of going to one and I could think of going to the other. So what angle would I be finding that time? If I'm finding the angle between, and these are the 2 angles that I have, which one am I finding? Wouldn't it be this guy? By the angle addition postulate?
Oh, yeah.
That one plus that one makes that one, so I can do that one minus that one to find that one.
Yeah.
Like that would be the angle between that I could find. But what if I were to draw, say, a different picture? And what if I was to do something like down here? Then I would be going to blue, and then to green, and then I would be, geometry would get tricky. Now, long story short, could this take a lot of work if I needed to graph the 2 lines, figure out which one is like more steep or sloped with a larger inclination, and then try to subtract the 2? Yes. So actually, we don't make you do this every single time. But I wanted to show you the idea of what's going to come up as just a formula over here. The idea is that actually, I could summarize a lot of the work that would be required, and I could get to where I have one consistent answer instead of having to think about the geometry and say, but there are 2 answers, which one do they want? They kind of just let me not do like discovery every single time, but instead say, hey, here's a formula, this is the one we mean, this is the standard, this is the one we want. Let's go ahead and plug in for those 2 lines, and we'll see if the one that geometrically we would have probably arrived at, whether that's the one they wanted or not. But this is the standard, this is the one that we're going to be finding. So when they say find an angle between, they're looking for the one that is related with the tangent of the angle being the absolute value of m2 minus m1 all over 1 plus m1 times m2. I think this is the exact same one that we just did, so you don't need to rewrite your example. I'm just saying from what you found, you guys did figure out that the first guy's slope was a positive 2. You guys found out that the second guy's slope was a negative 3 over 4. And the really cool thing is, do we even have to worry about the b's if we're just able to look at the relationships of the slopes?
No.
Nice! So good job reviewing that. But the nice thing is, it's like, well, if tangent of a theta is related to slopes, can we just use slopes to solve? And the answer is definitely, and here's how. Definitely, and here's how. We go ahead and plug into our formula. Say, what happens when we take, which one's 2, which one's 1? What do you guys think? Does it really matter?
2 should
Probably
be
the first one is 1.
Right.
2x.
So let's not make a big deal out of something that doesn't need to be a big deal. We can say the second, we can say the first, like that's usually what we're talking about. But whatever, get it plugged in, right? So we have our negative 3/4 minus 2 all over 1 plus 2 times negative 3/4. For some of you, this is going to be a bit of a stretch because it requires you to remember fractions. But do we understand? I wasn't trying to roast, but it kind of turned out that way. Can't we multiply the 2 by 4 over 4 and make it a lot easier? Because then we have negative 3/4 minus 8/4 is negative 11/4. Is that cool?
Yes.
On the bottom, can I multiply this guy by 2 over 2? Wait, what is she? Why am I multiplying that by 2 over 2 and not 4 over 4? 2 is over 1. We got to reduce some quick fractions, and we end up with 2 over 2 minus 3 over 2 is negative 1 over 2. And do you remember that your fractions work with, well, first of all, absolute value, a negative over a negative is a positive. Let's just get rid of that. Absolute value of a positive is a positive. I have 11 over 4 times 2 over 1 multiplied by the reciprocal. And I end up with tangent of theta equals 11 over 2. Tangent of theta equals 11 over 2. And thus my theta would equal, well, Ryan, I think I'm bringing inverse tangent for sure in, because 11 over 2 is not a square root of 3 over 3, or a 1, or a square root of 3. So bringing that guy in, 11 over 2. It's a positive slope. It should be something between 0 to 90.
So you bring in the negative, the inverse when it's not in the.
Yeah. Otherwise, they could require you to write it with a radical, because it should be something that you're reviewing from trig. You know what I mean? Otherwise, calculator gives us decimals.
So the answer is 11 over 2. Wasn't thinking.
The answer to the right-hand side of the equation is 11 over 2, but I was trying to find an angle. And so similar to other formulas that we've seen in the past, to find the angle, we would go ahead and say theta is equal to tangent inverse. So you could write down a whole other formula, or you could just notate tangent inverse at the end. Does that make sense, right? I wasn't done until I had theta alone. So I took tangent inverse of both sides to get my theta, which is exactly what they were asking for. And I suppose to make it look all nice and gorgeous, I should have put the tangent inverse as well here. And I should have put the tangent inverse here.
Yeah, I'm just confused how to solve for tangent inverse without using a calculator.
Oh, buddy, I'm sorry. You just missed it. I did. I did. I plugged it in. So 79.695. 11 over 2 is not square root of 3 over 2, 3. It's not 1. It's not root 3. So I compared it to the ones that would come out of my cheater chart. Since it wasn't any of those, I had to go ahead and use my calculator. Is that cool?
Oh, okay.
So we could go back and we could say, okay, what would you have done originally? Well, originally we would have done, let's see, what's the inclination of 1? So we could have found, like, theta 1. Then we could have found, like, theta 2. Then we could have seen if the one that we would have solved for is the one that they actually wanted. It's okay. Believe it or not, we were distracted before they passed by. We could have seen if this is the one that we would have solved with our picture. In order to do this, we would have had to have gone ahead and done a quick little like tangent inverse of this guy, which would have been -3/4. That would have been a negative angle, so we would have needed to have gone ahead and added 180 like we had to do before when the calculator didn't get us all the way there. Then we would have had to have subtracted tangent inverse of 2. And we could see if this would be the exact same thing. Please ignore the kids that are being so rude in the hallway. Hang in there. Second tangent inverse of -3/4 plus 180, because that's going to be a negative number. And then we could do minus second tangent inverse of 2. Hey, did it turn out to be the same thing?
Yes.
But what looks nicer? Drawing a whole picture and then having to think about both inclinations and then subtracting both inclinations, or?
The formula.
Yeah, that sounds good to me too.
Wait, Miss A. Oh,
Ready, set, go without a picture.
why'd you do like theta to one? Like,
Because according to my picture, I knew which one was bigger and which one was smaller, so I did the bigger and then the smaller to find the positive.
were you like checking if it was like right? Like, you know how you can
Yeah, I was just,
Oh, okay.
and the formula seems to be a lot more efficient as far as time goes. So yeah, we're just going to go with the formula, not with the picture. But to go with the formula, what do we still have to find? Not the b, but we do have to find the slope. Are you giving up or are you actually doing the work? So I think I hear a lot of giving up.
I am not giving up.
Oh my god.
No one likes up with it's like this.
Absolute value of a negative is a positive.
I think I got it.
I think I just rounded that wrong. Double check my math. Let me know if you see something that's wrong. There's only one slide left, and usually when there's only one slide left, we're basically done because the one slide says, hey, just do your homework. But question, is this just Algebra 1? No, we're bringing in some trig, and we're also kind of introducing some calculus, something to do with a tangent and a slope. Maybe you have to calculate. Otherwise, you guys are finishing up. You're done with notes. You're tackling homework for Monday. Monday, chapel day, class time. And I'm stopping the recording. P.S. For those of you guys that just joined us, because we paused for a little bit and came back, I just said if you want to double check my work with all the common denominators, I did remind them absolute value of a negative is a positive. But then I also went into my calculator and I threw in the whole thing, reminding them that this is a capability of their calculator, and yes, my work was right. All right, cool kids. See you later.